Hi guys, I hope you can see the table here. If you cannot see me, who cares? What I'm going to explain today is something that we passed in the theory when all the forces are vertical with the axle, because it's a very typical problem in statics, and I'm going to explain very simple problems in which you are be able to find the reactions very easy. Calculations can be made even by heart. Let's see, at the beginning all the forces, there are forces, the blue ones, and moments of forces that act in this or this direction, it doesn't matter, but they're all vertical. To be correct with the supports should be like this. You see, A supports have two unknowns and B support as one. A has a vertical and horizontal reaction, B has only vertical. However, because there are no vertical forces, cannot be vertical reactions. So that's why if you see the previous exercises, we have not been very careful on purpose for those supports, because who cares? They are going to be the same anyway. Let's see now what is going to happen. Let's see, for example, the first one is the force P in the middle. These distances are A and A. So how should be the reactions? Of course the reactions are going to be the same. Half of the force has to be held by the support B and half of the force by the support A. Very easy. Now, in the second case, what happened if the force is closer to the support A? I'm repeating again, there are not horizontal reactions because there are not horizontal forces. If you write the equation sum of the forces in the axle horizontal equals 0, you are going to find that XA equals 0. Let's see the second one. Of course, now the sum of the reactions should be again P. So half and half P should be again P, but the support A is going to hold more because the force is closer to the support A. How much more is the question? How much more? For example, if I want to find the reactions about in A, this is the reaction RA, what I have to do? Sum of the moments about the point B. Look here, force times 2A minus reactions times 3A equals 0. So the reaction is going to be 2/3 of the force. What is left for the support B? Of course, is left 1/3. So RB is 1/3 of the force. So now 2/3 plus 1/3 is the force. Look something. The reactions are distributed proportional, inverse proportional with the force. So this force that has closer reaction, this support that has closer force should have bigger reaction. How much big? How bigger? Proportional. For example, in this case, you see the old distance is 5A. Because the old distance is 5A and now the force is closer to the support B, if you reason the same way, this reaction should be 4/5 of the force. 4/5 of the force. You don't have to make the calculation. If you like to make the calculation, they are very simple. Reaction times 5 minus force times 4. So reaction times 5 minus force times 4. So the reaction is 4/5 of the force. What is left for the other guy? Of course, 1/5. And so on. It doesn't matter how they are distributed. If it is in the middle, half and half. If it is 1/3, 2/3 here, 1/3 there. If it is 4/5, so now here's 4, this is 1, it's going to be 4/5. So all the time, right away you can find the reaction. Look now this exercise here. Now, This force is acting on outside the support. We call it console. So this force is trying to give to this shape to my rod. So what's going to happen? The reaction now should be this way to hold it. And look, if we take the sum of the moments about point B, the reaction times 3A, force times A. You remember the story I told you with that lady in the seesaw? Now, if those distances will be the same, this reaction here will be equal to P, the same weight. Distance the same, force is the same, the moment zero. But the distances are not the same. This distance is A, this distance is 3A. So the reactions to be zero, so the total moment to be zero, this force should be 3 times smaller. So right away you can write P over 3. Look, P over 3 times 3A is 3PA, times 3A is PA, P times A. So it's the same thing. You can, of course, you can calculate by making the sum of the moments about the point B. But as I said you before, we have to think first before we calculate. People that put numbers before putting their brain, it's not us, we're engineers. We think first, we see first, after calculate. You see, if the distance, what if this distance, for example, was 2A? This is going to be half. So now, this is P, this is, what is left for this guy? This is 4 over 3. So because this P is, I can write it 3 over 3. The sum should be 0. So this is what? Plus 1/3, 4 over 3. Now look, now in the 3 last exercises, the load is the moment. The moment we said is a good guy. What does it mean it's a good guy? Doesn't bother us that much. The moment is a couple of forces. So if I write the sum of the forces in the axle vertical, in order to have equilibrium, those two forces should be equal. Otherwise, won't be zero. Of course, I don't have forces in the horizontal axle. And because the moment is rotating clockwise, the reaction should be counterclockwise. You see now? You see the one in the brown color? This is rotated this way, this is rotated the other way. How much should be those reactions? The reaction should be as big as to give the moment equal to m. So you see how much the reaction is m over 2a, and this one is m over 2a. I can find it differently by writing the sum of the moments about point A. You are going to have the same result, but I want you to think first. You see, m, how much is the moment of a couple? Force times distance. M over 2A times 2A equal m. M rotated counterclockwise, m rotated clockwise are going to have the same result. Look at this exercise. What do you think is going to make a difference? No way. We said that this moment is a good guy. What does it mean, good guy? Put it everywhere. You see the 2 last exercises? Here I put it in the middle. 2A to A. So the distance here, I should have done maybe better. So this distance is A and A. But still the distance is 2A. 2A here, 2A here. So the reaction would be the same because we said that the moment is a free vector. Take it everywhere, it's going to give us the same value. So it's going to have the same reaction here, m over 2a, and here m over 2a, and the same here. It's no reason to repeat it. M over 2a. And look the units. The units of the motor, of the moments. Newton times meter divided by meter. Newton is the units of the reaction. So these are very simple exercises. So when you see this one right away, you have to think of the result before you calculate for the result. That's all I like you to do, guys. Thank you for your attention, and I miss everybody. I hope to see you again soon. Bye-bye.